Alright, so we spent time on this yesterday. I want to get my credit in, as it were. So we're going to finish it. Then why could I get through 57 of them? Curious. Alright, so let's think through what this function actually does. Okay, so we have string cycle function with string, position, hash, char count, char.count, and list char. Okay, makes sense to me. If negative position, okay, that would be our termination condition. Could we dope the string? Yes. Yeah, I think this is gonna raise a question we've answered in the past. I'm not sure we're gonna like the answer this time. If negative S position list cycle less than this is the end, and what we're doing is sorting based on char min. What does that mean? Why are we sorting them in lexicographical ordering? Right, so the rule set for the transformation we're performing, let's see. Racket, because I'm already expert at it or learning it. It's the only language I know. So, I don't have any other options. Because I have not yet learned another language. Okay, so we have sort. We're sorting based on lexicographical ordering. And that's because the rule that we're following here. Remove the smallest character from S and append it to the result. Well, wait, we don't yet know what's in this list, so let's ignore that for now. Hold on. Log chat up here. Alright, so we'll ignore that for now. So let ref count slash boolean. So we take the current string ref position and we pass it through our hash table, returning false as the fallback position, and then we use the boolean value as our if condition. Okay. String cycle function, so if there is a ref count, okay, if there is a ref count, then let's see. We run string cycle back. Okay. With S-string sub1 position, normal list char. We already have a copy of it. So part of what this process is doing is obtaining all of the distinct. Alright, so how about we do distinct. Okay. Now, so we already have a copy in our list, so we don't need to add another one. Okay. You know, we're already setting up a let definition. We could do let star and put in string ref. Okay. Active char string ref s string s position. Okay. Now copy that through. Is this a functional language? Yes. The question number is 1,370. At the moment, we've already completed the daily, so I'm finishing up a problem I started yesterday. 1,370, increasing, decreasing string. Okay. So, we ask ref count slash boolean, so do we have a count already? If so, we don't need to add that char to the distinct list, but we do need to increment the count. Okay. Makes sense, and then otherwise we need to increment the count. Well, we need to give a count. We're indexing to 0, confusingly. For some obscure benefit later. Alright, and then const active char onto the distinct list. Alright, now at the end, we are sorting the distinct list based on char less than. Okay, and that's because we are removing the smallest character from S and appending it to the result, which means consting it onto the front. Then we remove the smallest character from S that is greater than the last appended character. Okay. Then repeat step 2 until no more characters can be removed. Then remove the largest character from S and append it to the result. It sounds like you would repeat the largest and smallest, but that does not seem to be the case. Okay. So we go to list cycle less than, which is to indicate that we're currently in the less than ordering. Okay. With a pre-doped list doped with open curly brace. Okay. We have our pre-string, which will get turned into a string at the end. Then we have our less than list, and we have our greater than list. Let's call this pass list because this is too confusing. So greater than list char will be pass list char. Alright, and then here, yeah, okay. Less than list char will be pass list char. Right. So now we take car of our list of chars. No, actually, I guess we're automatically doubling up. Because we pass the list back after the last element has been used. And then we use that last element immediately again. Okay. So, car of the less than list. Then we have ref count. We run hash ref, that gives us our count. So if the count is positive, okay, that means we have a copy, and it is not the last copy. Okay, don't we want to index to 1 then? Well, apparently not if we pass so many tests, but yeah, that's confusing. Positive ref count. Yeah, I don't understand this practice of indexing to 0 in this case. Well, no, I mean, I see how it interacts because we're saying positive ref count, and we pre-doped the hash table with open curly brace to 0. But we could also pre-dope with open curly brace to -1, for instance. Okay, and what would that do? Now we get a ref count, it's -1. But we do need to make a distinction, actually. Right. And that distinction is whether we const the element onto the passback list. Okay, so the list that we're passing back to list cycle greater than is going to, well, we only put elements back, we only put elements into the passover list if we still have a copy. If we have a positive ref count, we still have copies, so we const into the pass list in addition to consting into the pre-string list. Okay, now we ask if this char is less than open curly brace. Okay. Which is greater than all of the chars. Then list cycle we pass back to less than and we don't const the char onto our pass list. We do const it on a pre-string list. Alright, this is our curious termination condition. We're asking if the pass list... We're effectively asking if we've const any elements back into the pass list. If we have not const any elements onto the pass list, then we didn't const any elements into the pre-string list. Then the same idea, except that we're passing back here. Passing back to the greater than function. So what is going wrong with our output? Yeah, that's difficult to determine because the examples that were being given, the test cases that were being given are useless. Well, if I remove this reverse, why would we be reversing? Yeah, I don't think it was correct to run reverse at all. Okay, but then that presents a problem because this is the wrong answer. This needs to be reversed. Maybe the point is that it needs to be reversed in both cases. Uh-huh. So we'd recently passed out of greater than. Yeah, we terminate in list cycle greater than. Why would this need to be reversed? No, yeah, that makes sense, doesn't it? Yeah, and there isn't a way around that either. You can't start at the end because the order. Yeah, I'm gonna have a hard time explaining why you can't start at the end here. You can't avoid the reverse by starting at the end. I think the point though is just that we reverse in both cases. How we passed 57 cases without that being a problem is unclear. Let's copy this over. See if we can get this to work, and then we'll do an optimization pass. Okay. Hmm. $60 milliseconds. Maybe we could figure out a way of isolating the termination condition. That would seemingly have to do with... No, yeah, that's a problem. Because you would need to... You can't do it based on the length of the initial string. You have to know the distribution of elements to know how many times you have to go back and forth. So skipping consing an element onto the list is doing the work of shortening the list for us. Though it's also necessitating remaking the list every loop cycle. So we have to pass through list cycle, and we're consing elements onto our pass list. I mean, we could otherwise keep a forward and a backward copy. Except again that we wouldn't have the opportunity to thin out those lists. Yeah, we'd have to run list remove every time that we got the case where we would skip. It's possible that we could redefine these as for each. So this would be for list. We could dope the string for this initial pass. We could also we could dope the string, but we could also run string to list. And then see if we can fold left through it, I guess. If we did this with heaps instead of lists, and the idea would be that instead of removing from a list, we'd be removing from a heap. We get a fresh copy of the heap every time, anytime we encounter. And what this saves is list operations. Alright, let me look at heap. We have vector to heap, but we don't have list to heap. Okay. So let's copy this over. Successful slow. So what number was this? 1370. Okay, so now we're going to try to do this with heaps instead. Okay, so how do we do that? Distinct heap, distinct greater heap, distinct lesser heap. Alright, no one is gonna like that ordering. Everyone's gonna hate it, so let's do that. Alright. Now what? Now keep these. And then begin heap add. Begin heap add. Distinct heap less than active char. Heap add. Distinct heap greater than active char. Okay. And then we pass forward this instead. Okay. Alright, so now we don't need to run a sort. We're going to send in distinct heap less than permanent, and distinct heap greater than permanent. I don't really like that ordering. Alright, let's do like this. We don't do this, we also don't do any doping, which means that we're going to have to change list sickle. No, yeah, we could dope the heap. We could dope the heap to, and maybe even want to. Alright, so list cycle. Heap cycle. Okay. Now they both have to have both arguments. All of the arguments. Okay, now can I rename? Yes, here we go. I guess this begin. Alright, now what? So we want to call one of these permanent or immutable. Alright, how do I want to do that? Yeah, this might be worth a symbol. Okay, yeah, that makes sense. We could put an exclam on one that's mutable. Yeah, though, I mean, you probably want to reserve the symbol. Yeah, because it raises the question, are you going to do this for every primitive data object that you use? No, so it would only be in the case where we're differentiating a mutable copy from an immutable copy. But okay, that's reasonable enough, fine. So, similarly down here, let's see. Okay. So this is going to be heap min distinct less than heap exclam. Okay. Nope. Greater than heap min distinct greater than heap exclam. Okay. Now here. So I can do heap remove min up after the let definition without introducing a begin. Heap remove min, is that with exclam? Yep, heap remove min, heap, nope, distinct greater than heap exclam. Okay. So this should work the same. Let's see. We need these. This is getting a little bit confusing to me, but whatever. Right, and now this will be, we can copy and paste down here. Look how modular my code is. heap remove exclam distinct heap greater than distinct greater than heap this thing. Okay. Shouldn't that be less than? Yes, it should be less than. Okay, hold on. Okay. This is somehow going to take more time than rewriting the entire procedure. Curious. Yeah, I don't know what this termination is supposed to end up being, which is going to be a problem shortly. Alright, how do I create a hash? Rather a heap. Make heap. Makes a new empty heap. Interesting. So we can't do. Interesting also. But no, because we need to be able to remove. Let me see here. Also, we might have to make copies of these heaps. We can test that if I say define a make heap less than heap add a 5 show me a Racket slash heap require what? Why? Okay, whatever. Data slash heap. Okay, show me heap min a. Alright, now I say define b a. Now I say heap min b. Alright, now I say heap remove min a. Show me heap min a. Error because it's empty. And now if I ask what is heap min b, also an error because it's empty. So yes, we will have to make copies. Okay. Keep copy. I'm getting the feeling that this is not going to be faster. Okay. Can I ask heap empty? Well, no, it would have. We'd have to dope the heap, and then we're gonna have. Yeah, this is getting a little bit more troublesome than I expected to convert this into a heap problem, but. A heap solution. I've been a day off all week. I thought today was Friday. Well, rather, I thought yesterday was Friday. Confusing. Yeah, deeply confusing. Allspice, apparently. I wonder if allspice is. Never mind. Allspice, what I have been missing. I put it into my apple cider vinegar, lemon concoction, lemon water. It's pretty good. Alright, yeah, I don't know how to check. I think the idea is that we ask char equals heap min, which is exclam, right? Yeah, heap min, distinct heap, rather distinct greater than heap. Plausibly, that is correct. Heap, which has the same number of letters. Require racket, data slash heap. Actually, there's a different problem here, though. We need to dope the heap. And yeah, we're not sending in the correct arguments at the moment. Oh, so actually what we could do, instead of running heap copy, we could, yeah, I'll do that as a branch. Create for heaps instead of heap copy two of them. Okay. Speed branch. Okay, now I just want to do this with lists instead. Oh well. Yeah, we have to make a let definition here. Let heap less than heap, make heap greater than heap, make heap. Okay, and now this, let's see, heap add, oh, this needs char greater than, this needs char less than. heap add less than heap, and then heap add greater than heap. Okay. And then we send in heap less than and heap greater than. Okay, we close the let definition. Alright, that looks correct. Go. Heap min indeed does not have an exclamation. Okay. Let's copy that word so I can do it with my left hand. Okay, apparently. Okay. Right, so that's gonna be here. Okay. 30 minutes of typo editing later, here we go. Let's see. Yeah, went infinite. Alright, I'll be right back. Alright, so we can't, display the heap with primitives anyway. Oh, no, but we have char less than. Yes, okay. Oh, I see the problem here. I think. So whenever we call back to the next procedure, we need to... Oh yeah, actually we could just do this once. But that doesn't work either, because if I send in, I'd have to do heap copy every time. It's still going infinite, really. Yeah, but I mean, I feel like this... Well, I mean, we otherwise have to perform list operations over and over again. Yeah, why is this going infinite? Probably because our termination condition doesn't work, but well, but why not? Actually, I don't think this saves the time that we think it does. And the reason is that we're not using heap min. If we have to access... If we have to run heap remove, this operation takes, oh yeah, big O of n time. So actually, using the heaps is a mistake because the... Well, the only benefit to using the heap is... the sorting, the auto sorting that we get as we add elements. But yeah, that turns out that's a big mistake. Now I can do, let me think. Well, yeah, I'm not pleased with 60 milliseconds as our time, but then we need to get back into the habit of figuring out Emacs. I don't want to skip that. This is a cheaper solve, I think. Just delete that. I think this is a cheaper solve. What do I mean? So we'll have distinct less than, distinct greater than. You're raising the question of whether it's better to sort once and then reverse, or well, we could test that, right? Let's see. List generator. So we want to ask the question, is it better to sort first and then, let me think. So we're going to define a miniature function here, define double list. Function input list less than list greater than list. Alright, so if null input list return sort, let's see, const sort less than list. Could we do this as for each with a on A? No, because we would have to sort at the end. Okay, sort less than onto sort greater than list greater than. Otherwise, double list function with CR input list, const car input list onto less than list, const car input list onto greater than list. Okay. Now, so that also affords a different test we could perform, namely let definition or not. Alright, so now we want single list. Okay. And now we're going to say let sorted less than list, sort less than list, less than, and then we're going to const sorted less than list onto reverse sorted less than list. Okay. Alright, so time single list function A null. Okay, and time double list function A null and null. Okay. 328, 327. Oh, look at that. It's like twice as fast. Huh. Yeah. It really is. Okay. Now that we know that, what was the other test that I wanted to perform? Alright, well, so we could do this with let versus not let. Alright. So now we know we want to do one list and reverse it at the end rather than making two lists. And now I'm going to copy this over, and we're going to have so let car input list list. Okay, and now we're going to copy that. And then as normal. Okay. Close the let definition. Oh, it's so much slower. Yeah, it's real. That is slower. Look how much slower that is. You add this let definition, and it's horrible. It's not worth it at all. Alright, so shedding let definitions for car operations is a go. We're not getting... we could set up a test actually, like how many times would you have to use car before it's worth, and it might never be worth, it might always be cheaper just to take the car, I don't know, car of the list. Alright, well that's interesting. I mean, it could be the same point here actually, where we'd rather take the string refs and the hash refs. Alright, so we're not going to have two lists. We're going to have one. Alright, and then we're going to let sort distinct less than list char char less than. Alright, and now this will be sending and then we need to run sorted greater than list reverse sorted less than list. Alright. So that will be send sorted less than list, sorted greater than list, sorted less than list, sorted greater than list. I'm once again guessing that this is not going to be as efficient. Not for nothing. Do I need to close something here? Yes. Alright, now the same idea, we're going to say mutable, which doesn't actually specify whatever. Alright, so now mutable. So actually we can shed this less than argument. Okay. Uh-huh. Yeah, this is a little bit more complicated, but we'll deal with it. Okay. So this needs to be char greater than bracket. Our termination condition needs to be something else. Unclear as of yet what it needs to be. Yeah, that works. So just remove this. We'll just do send in null because we can do. Oh, we also need. Okay, and then we come back up here. Sort. So this is gonna be CDR of reverse const open bracket, and this is going to be sort const open curly brace. Okay, and now first try, what do you say? Yeah, okay, we can change that to distinct. Expected 7. Right. Okay, now we have to figure that out. Oh wait, isn't that just no, it's more complicated. Yeah. How do we figure out that we're empty? Instead, it's car of less than list. Well, that's interesting. We have to remove from both. Okay. Okay. Let's find out, shall we? Hmm. Hmm. Why are you doing this to me? Let's see. Car, positive ref count. Okay, let's see. Display. What? Oh, okay. And if I come up here, not the same problem. All right. Okay, list cycle less than expected 7. Why would you expect 7? How are you still here? Deleted 400 copies of that. Oh yeah, okay, apparently that's still there as well, and that apparently as well. Okay, sure. Yeah, again, I feel like I've deleted so many copies. But okay, there we go. Alright, now let's copy this over. And delete the displays. Is this going to be another day where we don't practice Emacs? Is that what's happening? We're at a disadvantage every time. We're losing time every time we use our Dr. Racket ID. Wrong answer. What would make it work that long and then fail? Why did we succeed for 221 test cases before getting such a wrong answer? So we should only have two E's, and that's because yeah, okay. Yeah, so there's only E has a multiple. Okay, so we should have removed, in this case, well, what did we deposit? Yeah, okay, let's see. Display pre-string. So we deposited, let's see, pre-string is null, pre-string contains C. That makes sense. Okay, we deposited C. Wait, I misinterpreted this. We deposited all of these. One of each. Okay, and now the question is, I see. Okay. Okay, so as it turns out, we don't need to send this list. Let's fix it first, and then so it's in the handoff when we hand greater than exclam list instead of greater than list. And the point is that we haven't removed elements from the exclam list. Okay, but that also means that we don't need greater than exclam here. Okay. Was that the correct one to delete? Wait a minute. Less than, greater than, less than, less than, less than. No, that was not the correct one to delete. That's the takeaway from that. Yeah, okay. Alright, now what? Let's see, so we don't send that. That is correct. Okay. And we're gonna get a worse time. Which will be a little bit deflating, but then we'll know. Worse rather time indeed. Okay. Yeah, well, those removes are expensive. We could use a stream instead and run stream filter, stream remove. I mean, actually, you run stream remove, and the idea is that you pass forward these stream removed streams, and then instead of running the remove operation, yeah, but I mean, we've consistently found that streams are just slower no matter what. We have yet to run into a use case where streams are faster than lists. I mean, that's up to and including running expensive list operations that we get for free with streams, or where we can run stream filter or what have you. It's not faster to put a stream filter on a stream than to run remove, apparently. We could try it anyway. Yeah, we have about 35 minutes, 36 minutes. So the idea is that all of these are going to become streams. Looks like no stream remove. No, we'd have to run filter. We could do that, though the fact that it's filter instead of remove makes me suspicious. Okay. What instead? We could put our chess time now. That makes some sense, I think. I could spend a little bit of time doing that, or hold on. Wow, that is horrible. It's a lot to have pop up. Here's a cartoon animal. Do you want to look at a cartoon animal? Here's a cartoon woman. Do you want to look at a cartoon woman? No. I don't know. It's stylish, but glaring. Let me see. Alright, so this is string solution. No, rather, double list solution. So we'll post the 60 milliseconds. We could also put off the, yeah, well, we have to figure out whether we're going to be claiming time from the beginning or the end of the exercise segment. I suspect it would be easier to claim time from the beginning, but then inconveniently we ran out of activity. I don't know if 30 minutes of Emacs is going to be worth. Alright. If I spend 30 minutes in Emacs, I'll be able to figure out how to move the mouse an inch before we hit another roadblock. Alright, well, I guess we'll take a break here. And when I return... Exercise and thinking out loud. Oh, well, why didn't we learn our lesson? Right, we could have removed these let definitions. Actually, yeah, we could do that. That's a little bit horrible to do, but, well, I just find and replace. Yeah, okay. Okay, now we go down here. Okay, and then ref count. Curious, okay. Actually, the last thing to do would be to dope the string. Actually, is there a dope to perform? Here, so we're cycling through the string, okay, and we're wondering if there is a Boolean. Let me think here. Okay, so we can do that with open curly brace. Okay. We should have copied. Yeah, we can copy over. Undo all of that. Okay. Now, so, let's see. Define first box char string ref S0 string string set s. Yeah, we can run 2 tests. Yes, okay. Let's run 2 tests, because I mean, could be that. Okay. Okay, let's see. What did I do? We also didn't delete the let definitions. Indeed. So car less than. Okay, that was strange. Let's see, we also need to delete this let definition. Strange typo. Alright, that's correct. Alright, let's send it back. $63. Yeah, well, we're doing a million elements in our speed testing. Okay, so doping the string is the only remaining, and doping the string is actually really easy in this case, I think. String set S0, curly brace. Okay, then sort const first box char. Oh, actually we don't know if first box char is distinct. Yeah, huh. If href hash char.count first box char false, then it's on, otherwise sort distinct list char, char less than question mark. Okay. We didn't change the hash. Yeah. All right, let's make this if. Let's take this if out here. We have to add that here as well. So this would actually be 0 because we got back false. And now this is going to be hash set hash char.count first box char add 1 hash ref hash char.count first box char. We need a null after that. We need a list. Okay. Oh, is this broken now? No, apparently not. Yeah, I mean, we're not avoiding. We didn't do null check here, and now we're not doing null check here, so that's not a change. Why would this null me out? Oh, it's easy to dope the list. Yeah. It's easy in this case. Oh yeah. I don't understand how this is any different. Oh, well, I mean, it's kind of strange that we did the list doping and then we didn't do anything to take advantage of that. You know, that's an interesting point. Yes, cond ref count slash boolean. We'd have to use negation. Alright, but I'm ready to junk it. We have to use negation. And then... let me think here. Well, alternatively, we don't. Alternatively, we don't dope the hash and we guard it behind not having a hash ref. Okay. Okay. Char equals active char. Okay. Hash set, no, rather. So now we're gonna call. So we could do char alphabetic. Active char instead. That might not be the correct command, but let's see. Hash ref, hash char.count, first box char, false. Then I'm losing it. I'm losing my coding. I need my coding. And now we have a nice, clean cond stack. Okay. And we're gonna get an error because I didn't change anything. Oh, we have to write hash ref or hash set. Oh yeah, that's kind of horrible. Hash set this thing. It's circumstances like this that make me doubt the wisdom of immutable immutable hash tables. I have serious doubts that immutable hash tables are a good idea. Nope. All right, well, last check here would be, say, is it better to have an immutable hash table? All right, we'll do make hash and just impose 10-15 minutes of effort on myself. Let's see. So we could also put exclam after hash to indicate that this is a mutable hash table. Make that the habit. Okay, sure. So this would be hash set. We don't have to use begin. All right. Why is that over parent? That doesn't make any sense. Okay. Again, this takes as much time as rewriting the entire procedure. It takes a bizarre amount of time. Okay. Yeah, well, notably we don't get our speed boost from copying and pasting. That's an interesting point. Let's see. Run. 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 Go. Let's see, delete that. Wait, what happened? Hold on. I have to do both of these hash sets. Okay, that'll be it. I'll take that, please. What was that? What did that change accomplish? Right, we now have a mutable mutable hash table. Let's see what kind of performance benefits we've been missing out on by using immutable hash tables. Huge memory savings. Okay, I believe it. 17 milliseconds, 101.55 megabytes. Use immutable hash tables. Okay, post. What is this? Why do I have a bell? No. Alright. Oh, edit. That is a huge... Alright, we're never using immutable hash tables again. Well, no, actually we will for... Yeah, I mean, well, it's because we're constantly updating. We have to update this all the time. In a lot of use cases, we build the hash table in one phase, and then we never update it after that, and that would be the candidate for mutable. Anyway, let's save this as... I will take a break. We're back, and then we will do other things. Okay. Hello. Keep it real. You don't want it unreal. It's time to exercise and think out loud. Are you ready? Was that a goodbye? I get 1 minute to respond. Oh no. Well, though, I suppose if you clicked on leetcode, Racket leetcode, and then it was this, it's not going to be what you're looking for. Let me see. I find it more difficult to think when I have the monitor on. I find it more difficult to think when I have the monitor on. Well, I'll keep it real. Alright. Let's see what my knee feels like. feel it in my knee. Well, legs are out then. Yeah, it's just part of why I have the heater going. Space heater. It's an important point I've skipped off of a few times. Interesting point that it's easy positively to explain. When you are following a rule set when you're following a rule set, it's easy to explain why you're doing what you're doing. You can appeal to the rule set. There's a requirement to let me see here. If I am not following a rule set, you ask me, why are you holding your hands like this? I mean, you know that I'm doing this exercise where I'm pushing my hands against each other, but why at this angle? Why do you have your arms in this position, these positions? And now if I was following a rule set, I could appeal to the rule set, but I'm not following a rule set. And now it's sort of... Well, and yet I do find positions where I do find positions to move my hands into, or to move my arms into. I don't know what point I'm trying to make. It's like I'm exploring for new muscle groups I can light up. And you say, well, what makes you think this is a good way to explore? As if, I mean, there could be a systematic method of muscle exploration. You could follow a grid format, for instance, and cycle through it. Okay, so you are positively choosing something other than the grid search. Okay, why are you choosing something other than... Why are you choosing this thing that is not the grid search? Now, if I was following a rule set, well, then grid search is essentially any rule set. I mean, I illustrated the grid search, such as I wanted to call it. But any other rule set would also be, well, it would be like grid search in that I could say, allow me to demonstrate this rule set. Okay, and it could have been any rule set that I just performed over the last few seconds, as an example. If you had to come up with a rule set to describe the muscle groups I'm activating, the pattern that in the muscle groups I'm activating, it would have to be weird and wonderful, or it would have to be singular and bespoke. If there was a general description where this is an instance of that general description, it would have to be a strange general description. And then alternatively, instead of a general description, you could have the particular description. You say the rule set is the rule that tells me to do exactly this. It's a rule set that tells me exactly what to do in every instant. Or we identify a critical finite sequence of positions and we say the rule set is to go there, then come back, then out, and then back, with no commentary on why a rule set would dictate this sequence. My feet spilled some water on the ground earlier and my feet have been frigid since. Probably because the ground hasn't dried. Yeah, probably. Well, I don't want to overdo my upper body either. Careening from injury to injury. Hold on, there's a question I want to ask Internet real quick, though. Interrupting my thinking by asking the Internet a question is... that raises a question, doesn't it? Well, oh well. Well, I can keep going with my game against the engine. This is an exciting new form of exercise. Exciting new variation. Actually, we had a recent leetcode problem where we had time limit exceeded. I wonder if that used an immutable hash table. I can't remember what that problem was. Yes, it's easier to fill time. It's also easier to talk if I'm running, I think. But easier to fill time for sure if I have my legs. Strikes me to play music. There's an interesting sound playing outside. I think I'm going to play with it. See if I can do anything interesting with that sound in the background. Harmonize with it. Okay. How do I want to do this? It's gonna be cold. It's gonna be cold. Not fond of the cold, as it happens. I could do it without recording equipment. Or yeah, we could do that. Alright, I'm gonna head out. I'll be back. I might be back within the next 2 hours, and I will certainly be back before end of day. Alright. Have a good one.